Let me just get my answer ready here. Okay, so for page 50, just make sure you write this down if you haven't done it. So we're making cars and vans, right? It takes 6 hours to produce a car, and it takes 7 hours to produce a van. That's just information. There's no inequality just yet, right? The cost, right? It costs $7,500 to produce a car and $15,000 to produce a van. Respectively means, right? We're sticking with this order. And so now the restrictions start. Okay, so let's do let's define our variables. X would be cars, Y would be vans. This is number of. Okay, X and Y would be greater than or equal to 0. And that's your implicit constraint, that's B, so we're taking care of that. Even if I don't ask you for it, just write it. And now we're going to start with our inequalities. First restriction, the company needs to produce at least 9 vehicles per day to stay profitable, like to make money. So that's just talking about, right, the sum of both vehicles combined has to be at least 9. Okay, that would take care of that one right there. This is inequality 1, if you want to call it that. Okay, the maximum that can be spent is $225,000 per day. So there's a restriction on the amount that you can spend. So that's when you need to use, in this case, the cost for each one of them. So you go 7,500 X plus 15,000 Y. That has to be less than or equal to 225,000, right? Like you cannot surpass, that's the maximum you have to spend. Listen to this part, right? If I didn't have to say the maximum, I could have just said the company has a budget of this much. You're implying that that is the max you can spend, okay? So make sure you understand that. Next, there's another inequality. There are 115 hours of time available, of production time. That's when you're going to use the hours, right? You go up here and you see that it takes 6 and 7 hours respectively. So 6 times X plus 7 times Y, and that has to be what? Less than or equal to 115 hours. Everything is in hours, no need to convert, right? No need to convert. If it had been minutes and hours, make sure you convert to have everything to the same. And then the last one, this is the tricky one I warned you about. I would expect you to write these ones out if you see them. Due to demand, the company makes twice as many or more vans compared to cars. I was thinking, how can you rewrite this to help you out? Another way of saying this exact same thing, you should write this down, is for every car, you make at least 2 vans. I don't know if that helps you. For some of you, that's going to be more relatable. Like for every car, you make at least 2 vans. That's what that statement is saying, okay? So some of you might appreciate that. So that's when you write it out. And so you have your, I like to have the Y variable on the left side, so I will naturally always go like this and then decide which way to point the inequality, which way to put the, where do I put the 2 or the 3 or the 4, you name it. Because it could say for every car you make at least 3 vans, right? So just read carefully. So you make 2 vans. So in this case, the X would be my cars. So that's where you put the 2 in front. And you want the number of vans to be at least this much or more. So you have it pointing that way. So for every car, think of it this way, for every car, you make 2 times that amount for the Y. Okay? So I hope that helps you out. I don't think I'm going to graph this one, because this one is on the more difficult side when it comes to graphing. I would just expect you to be able to write the inequalities when you read it. So quite a bit on the test is going to be revolving writing inequalities. You will have some graphing, but not every single question, because it's way too time consuming, and we wouldn't be able to get that all in on a test. So let's keep going here. I know I asked you to do 57 or 58, if not both. I hope you've done that. I actually have a video that goes with it. I think I would like to do the sporting goods store for sure. If not, let me see here. Hold for now. So this is still on you for now. I'm just gonna go continue, keep going to 59 for now. This is the last piece that I need to add to your notes, okay? Optimization questions. And what's the difference here? We're gonna find the ultimate answer using our objective functions. So far we were able to graph solution regions or polygons. We were stating the POIs surrounding the solution region. If the question asks for a combination that will either maximize or minimize, so here's the word. This is the new part. If the question asks for minimizing or maximizing output, it is essentially asking us for the best answer. Okay? Finding the best answer. And the best answer will come out of one of the points of intersections. To determine the optimal solution, we need an objective function. And then we plug in the points of intersections into the objective function that will allow us to determine the best combination. So we're trying to find the ultimate, the best case scenario. And I'm going to use a different color for this one. You should too. I'm going to use something green in this case. The objective function is not an inequality and should not be graphed. Okay? I will even circle that one. Do not graph that one. So for instance, this is what the objective function will look like. Okay? C is equal to 3x minus 2y. We will learn how to come up with that shortly. But if I ask you to determine the optimal solution that would either, let's just focus on maximizing output and then we'll focus on minimizing output. So what you do is substitute POIs into objective function. There's going to be an objective, right? Like a goal that we want to achieve. So here it is. We take our first corner point here is 7, 6. Okay. I'm going to go a little further down because I need space this way. So I'm going to take the 7, 6 and plug it into C. So that'll be 3 times 7 minus 2 times y. So I'm plugging it into the top here. So that'd be 21 minus 12. That would give me 9. You move on to the next one. 7, negative 9. You have, sorry, I'm going to go 3. Again, 3 times 7 minus 2 times negative 9. That ends up being 21 plus 18, and that adds up to 39. Next is 28 negative 9. You plug that into C. It's 3 times 28 minus 2 times negative 9 again. So that would be, that gives you a total of 102, like that. Now the question is, which one of these three maximizes your output? You just look at your answers. This one will maximize. This one will minimize. And you're thinking, what's up with that? In some cases, you're going to want to minimize the cost, right? A company wants to minimize the amount of spending to be able to make as much money, right? And in other instances, we'll focus on the profit, right? How much money you make. In that case, you would want to maximize your output. So you would want to pick this combination here, okay, to maximize. So let's do a word problem together and see where that leads us. So I'm doing 2-in-1. Today I'm showing you how to graph, how to come up with inequalities, and introducing the objective function part. So go to 61 here. Make sure you write this down, stay on task, okay? On the test, I will probably put bullet forms most of the time when it's a word problem. Like, so you know that's my inequality, okay? Inequality, inequality. So I'll try to do it in bullet form. A parking lot has an area of 540 square feet of space available. A car needs 9 square feet of space, while a bus requires 36 square feet of space. So all of this has to do with space, right? How much is there available? 540, so it's up to 540 square feet. The manager of the lot does not want more than 45 vehicles on the lot at a time. Okay? The lot has a minimum of 10 cars per day since there are people working close by. State the variables and the implicit constraint. Let's do that first. X, Y. What would you say X and Y would be in this case? Cars and buses? Yeah, sure. Cars and buses. Number of. And so that's discrete, right? Discrete data. Let's do our implicit constraint. You should be able to close your eyes and do that with eyes closed at this point. Okay? And so let's do the writing inequalities. Let's highlight things that give it away that there's an inequality that should go with it. The first one would be there's an area of this much available, correct? That there's a restriction on the space. So let's come up with that one. This is IQ 1. So that would be what? 9x, because it's 9 square feet for every car, plus 36y, right? That's how much space every bus uses up. That has to be less than or equal to 540, or else you're not gonna have enough room, right? So you can't go past 540. Then, where's the other one? The manager of the lot does not want more than, okay, you do not want more than 45 vehicles on the lot at the same time. If you need to update page 48 with these keywords, you go for it. That's IQ number 2. And so that would be what? What would this be? X plus Y is less than or equal to 45, correct? Yes. And then there's one more. Has a minimum of 10 cars per day. The lot has a minimum of 10 cars per day. That's my third inequality. So IQ 3, we would say that the X plus Y is great. Oh, does it say cars? Sorry. This is specific to cars, right? Almost slipped. Thank you. This is just cars. So X is greater than or equal to 10. That one is an easy one to graph. You like those ones. Okay. C's asking us to, no, sorry. C, determine the combination of cars that would maximize the profits, all that. Given that a car pays $750 and a bus pays $25. That one comes later. That's going to be our objective function, right? And what's the key word here? When you see that, we want to maximize profits or minimize costs. That is hint for objective function. So let's do the usual, rewriting, doing all that so we can graph these, okay? I will do that over here. So this would be 9x is equal to 540. Find the x-intercepts, right? And today just write them down. We're not going to actually... And then the y-intercept is 36y is equal to 540. Can you see that? Yes. Y is equal to 15, 0, 15. Okay. Perfect. Let's rewrite it. So I'm going to go 36y is less than or equal to negative 9x plus 540. Divide everything by 36. Y is less than or equal to negative 9 over 36. X plus 15. We know that this is 15. Circle it. You got to be careful with your space. I'm going to do all that, the extra work here. I'm just going to say this is a solid line. True region is, if it's less than that, the true region is below. We're going to shade above, circle that. Then IQ2, we're going to work with that. You love that one, right? If it's just X, Y, 45. Then guess what? It's going to be 45, 0, 0, 45. Those are my intercepts. That's it. I'm not going to show a whole lot of work there. Rewriting it is just y is less than or equal to negative x plus 45. Solid. True region is, if it's less than, it's below. Okay. And we're going to shade above as well. So both of them we're shading above. I'm just going to check my inequality symbol faces the same way. I expect to shade above for both of them. Okay. Got it. Now this one here. Let's do this one right there. This is just a vertical line at 10, 0. Okay. Solid. True region is where? It's either right or left. So it would be right. We're going to shade left. So hopefully you're pretty good at these at this step. So we're going to graph right now. We need to graph to come up with the right points. I'm going to use this whole bottom part here. That's why I gave you another blank page. So this is cars, buses. Let me just scroll down a little bit. Cars and buses. So that's my x and my y axis. And I'm looking at my values, and when it comes to the x, I need to go. I have 45 here, and I've got 60. So I'm going to go all the way up to 60 or 80. So 10, 20. 30, 40, 50, 60, 70, 80. That works pretty good. I'm just going to label every other one. And going up, the Y's, the highest that I see is 45. Should probably suffice. So 10, 20, 30, 40, 50. So here we go. 0, 45. I'm going to do this one first. This would be 45, and this is 45 right there. So I'm just going to connect that one. And just label it. And then the next one is 60, 0, 0, 15. Right, 60, 0, 0, 15. We hear you. You're pretty cool. We got it. You made your point. Thanks. There you go. That's my friend. Anyways. No offense. 10. We're going up. Before you commit to shading, kind of imagine it a little bit, or just lightly see what's going to happen. Because sometimes if you shade and everything is shaded, that means that you probably made a mistake or there's no solution, right? Guys, if everything is shaded, there's no solution. Everything is false. So you kind of have to be somewhat careful. So I'm going to go with a 45 here. It says to shade above. So I'm going to go right up to that one and just... How about you just do this to start? Right? And then the other one says shade above as well. This one. Shading above that one. Okay, so all of that is gone. And then this vertical we're doing to the left of that one. So if I just do a light shading, I see that there is a non-shaded part right here. So now I'm going to fully commit and just go ahead and shade everything. Okay. Everything is gone there. And then we do the vertical. And that's my solution region. So this is what we've been doing all along. Okay. Let's find the POIs real quick. Okay, so here's where you need to be smart about your POIs. I'm going to write them down right here. You can read a lot of them straight off the graph, okay? What's this one right here? We know that this one is 45, 0, right? So just read it. I'm just going to tell you that I read it off. This one over here, 10, 0, right? Don't use your calculator for those ones. It's going to take way too long. These two, you probably have to use your calculator for. I will cut to the chase and just tell you what they are. It's 10, 12.5. This one is a calculator. And this one here is 45. 40,5. Also use my calculator for that one. What's wrong with one of them? You can't have decimals because it's a discrete data, so you got to round. So that's going to be half a mark if you miss that. Discrete, round, okay? That's probably worth highlighting so that it sticks out. So 4 corner points for this one. So now on the blank side, on the page 62 is where we're going to do the new part, the objective function. Okay. So let me walk you through a bit of an exercise here. I'll say this. So we're just going to write this once. Write the objective function that determines, we're going to do this one, maximum profit. Or, you know what, can we just do profit? Sorry. You messed up my notes. That determines the profit. In this case, we use any letter that you would like to use, but because we're dealing with profit, you just go capital P. And what is the profit here? How much is this parking lot making with every vehicle? $7.50 for every car and $25 for every bus. This is the objective function that relates profit, that tells you all about profit. So let's plug them in. 45.0. Let's plug that one in. So it's 750 times 45 plus 25 times 0, right? That's almost irrelevant. And that gives you, 1 second, 337.50. Then you take the next one, 10.0. Plug that in. I'm gonna just worry about the 10. I'm not gonna bother with the 25 times 0 part. So that would be $75. So far 45.0 wins. Okay, gives us the highest profit. Let's keep going. 10.13. Make sure to write this down before the bell goes. Okay. 750, 10 plus 25, 13. You can plug that in as is on your calculator. You don't even have to do it in steps. And that would give you $400 exactly. So far, that one is winning, right? That's going to give us the highest profit, having 10 cars, 13 buses. And the last one is this one, 750, 40 plus 25 times 5. That gives us 425. This is the max. Which one is the min? Right? So we only care about the maximum, right? 40 cars and 5 buses will maximize profits. 1 second. I want to do one more. What if I asked you write an objective function that would relate space, like how much space I have? Let's just finish this one. Space would be what? A car uses 9 and a bus uses 36 square feet. So that would be space. One more. And then you can go. Number of cars parked at all times. Like how can you get the most cars parked at any time? Cars would simply be X plus Y. Okay? And what we would do is if I wanted to maximize or minimize the space, I would take all 4 corner points and run it through this one. Or all 4 corner points and I would run it through this one, okay? So that's how objective functions work. Hold on. You need to try this because tomorrow is basically the last day, okay? Page 63, 64. optimization. Basically what you're practicing is this last step of coming up with the objective function and figuring out the maximum or minimum, okay?